Hi, and welcome to the video on general formulas of polynomials. Before we move into notes, I just want to remind us of where we are in our map. So last time we were together, we built the road from data table to classifying by degree. And what that means is that now we should be able to classify a polynomial function if given its data table. The next road we're going to work on building is from data table to formula or equation. So what we're going to learn is how to find the formula and write the formula for a polynomial function given its data table. So that's what we're working on next. But before we do that, we have to learn a little bit about the general formula of polynomials. So all polynomials have a general formula. And let's just look at a few examples so you know what I mean when I say general formula. Let's start with linear. Now when you hear a linear function, you may think of the equation y equals mx plus b. And even though that is the equation for a linear function, in order to be consistent, we're going to use the same procedure for all polynomials in writing their general formula. So let's look at the linear example. The general formula is f of x equals ax plus b, where a is the coefficient in front of x and b is the constant. And you can see in the example that a is 3 and b is 7. Going on to the quadratic, the general formula is f of x equals ax squared plus bx plus c, and a is the coefficient in front of x squared. In our example, that's 5. B is the coefficient in front of x. In our example, that's 7. And c is the constant 9. Finally, for cubic, the general formula is f of x equals ax cubed plus bx squared plus cx plus d. In our example, we notice that there is no number written in as a coefficient in front of x cubed. So that value for a, you probably remember when there's no coefficient written, is 1. B is 7, and there's something missing for C. We're going to come back to that, and D is 12. Now, looking at this missing term here, what we must remember is that coefficients are multiplying with the variables. So coefficients and variables are being multiplied together. So if there's no number written or no term written, then we know that that coefficient is 0. Because 0 times x will give us 0, and so we don't write zeros in our polynomial functions. All right, so how is that going to help us? Well, the thing to know is that in order to build the road from data table to formula or equation, that is to say, in order to write the formula or equation from the data table, we must be able to find the values for the coefficients a, b, c, d, etc. from the data table. So let's practice writing the general formula of polynomial equations. Now at this point, this is where you're going to start taking notes. What I need you to do in your composition book is to write the date on the left-hand side, the page number, whatever page number you're on the right-hand side, this title, writing the general formula of polynomial equations, at the very top. And the next thing you're going to write are steps. Now as I'm going through this, it's your responsibility to pause the video. There'll be certain parts of the video where they tell you where you're told to pause, make sure you have everything, but it's your responsibility to pause it as well. So going on with the steps, the first step is to write f of x. We are trying to write a formula / equation. Remember, equations have two expressions written on either side of the equal sign, so we always want to start with f of x equals. Next thing is we use the classification to identify the highest exponent or power. So again, when we say classification, we're talking about classification by degree, so words like quadratic, quartic, 5th degree, 6th degree, etc. Next, we're going to write the first term. Now, our first term is always going to begin with the coefficient a. If you notice, the coefficients are going in alphabetical order. And since we're going to do this in standard form, the first term will have the highest power as well. And then we just keep going with our coefficients in alphabetical order. So the next coefficient should be b. And our terms, again, are in standard form. So it's going to be the next highest power. And we're going to keep doing that until we get to the constant at the very end. Don't forget that constant. Let's look at the example 1, which is a cubic function. All of this, including the example, must go into your notes. So first step, write f of x equals. That's the first thing I want to do. Kind of also grounds me to remember that I'm actually writing an equation here. Next thing, use the classification to identify the highest exponent of power. So this is where you kind of have to do some thinking. Well, I know that a cubic polynomial is a third degree. So the highest power is 3. The degree is equal to the highest power. So the very first term I want to write is ax cubed. And now I'm going to keep going. So the next term I'm going to write, my coefficient, if I have an a in front of it, of this first term here, my next coefficient must be b, because I'm going in alphabetical order. And then my next power must be 2. So the term I get now is bx squared. Notice I'm also putting plus signs in between each term. This is important. You're just going to put plus signs in between each term as well. Okay, I bet you can guess what's next. So we have b, that means c must be the next coefficient. And I have a power of 2 here, so my next power must be 1. So my next term is going to be just cx. And now the next coefficient is going to be d, because I notice that this is a c, so a, b, c, d is next. And I notice here that my exponent, there's no number written, so it must be 1. So the next exponent is going to be 0. Anything raised to the 0th power is 1. So what am I going to have? I'm essentially going to have d, my coefficient, times 1. And that's just d. So that's where the constant always comes from. That's why we always have to write the constant. All right, let's look at another example together. Don't forget that constant. The next example that we're going to look at is a 6th degree. And you're going to write this example underneath as well. So first thing, write f of x. Next thing, I want to write that first term. It's always going to start with a, and it's going to be ax to the highest power. So it's a 6th degree, so the highest power is 6. So I'm going to have ax to the 6th power. Then my next term is going to be bx to the 5th, because again, coefficients go in alphabetical order. And then cx to the 4th, dx cubed, ex squared, and bx. Am I done? No, I still have to put in that constant at the end. Can't forget to write that. All right, don't forget that constant. A quick way of checking to make sure that you've written the general formula correctly is to check the number of terms that you have. So what I want you to write next to steps, as I did here, put a star, check that the number of terms equals the degree plus 1. So in this example, this is 6th degree. I should expect to see seven terms. So 1, 2, 3, 4, 5, 6, 7. If I have 7 terms, it's likely that I did not make a mistake or did not skip a term somewhere. For smaller degrees, it's usually easy to do this. It's you can see when you're missing a term, but as you get to higher degrees, it's oftentimes easy to skip a term just by accident. All right, here's some practice problems for you. This is also going in your notebook. I also will be looking for this as well. So practice is to write the general formula for the following polynomials. I want you to also write that down. Practice, write the general formula for the following polynomials. So when you come back in your notebook, you know exactly what you were doing. Here's an example of what I'm looking for. So if you're given cubic, I want to see the polynomial formula written next to it, the general polynomial formula. There are 4 examples for you. Pause the video and work on these practice problems. And then there's one more set of practice that are related to these problems. All right, in practice B, you want to write down practice, identify and correct the mistakes in the general formulas. So in this case, you have 2 things to do. You're given general formulas and you're having to identify the mistakes. So we have an example here with cubic, f of x equals ax cubed plus bx plus c. What is the mistake? So remember my check? This is a cubic function, so the degree should be 3. I should have 3 plus 1 or 4 terms. 1, 2, 3. I only have 3, so I'm missing a term somewhere. And now I can go back and figure out what term I'm missing. So this one is x cubed, ax cubed, that's perfect. The next term I should see should have a power of 2, but I don't have that. I have bx, which has a x to the power of 1. So the mistake I see is I'm missing the second term, and I just go ahead and rewrite it in the correct form. You're going to do that with these 4 examples here, identifying and correcting the mistake. Pause the video and then come back for the rest of the video. All right, the next part of the video is to practice filling in data tables by plugging values of x into the general formula. So for this, we have this quadratic, and what we're going to do is we're going to fill out this data table here by plugging in our x values into the general formula. This is very helpful for us because this is what we're going to be doing to find a, b, and c, the coefficients for these polynomials as we try to write the formula from the data table. So now you're seeing the link between the data table and the formula. Okay, here we go. So for the first row here, x is 0. So what I'm going to do is I'm going to just substitute all of the x's I see in the general formula with 0. I want you to also write down the general formula in this column just so that you can keep track. I'm going to do my work on the side and not in the column just so it looks neat. So I have f of 0 equals a 0 squared plus b 0 plus c. I know that a times 0 squared is just a times 0, and b times 0 is b times 0, and then there's c. And a times 0 and b times 0 both give me zeros, so this all becomes 0, and then I have c left. And so the answer I get there when I simplify that is just c. Next thing we have to do is we need to substitute in x for 1 into this general formula. And I'm going to go ahead and do that again on the side. So I substitute in 1 for all of my x's. I get f of 1 equals a1 squared plus b1 plus c. 1 squared is 1. So what I get now is a times 1 plus b times 1 plus c. And there are no like terms I can combine. And a times 1 is just a, and b times 1 is just b. So all I have left is now a, b, and c. A plus b plus c. And I write that in there. Last but not least, I'm going to do this again with 2 and 3. So with 2, I get f of 2 is equal to a times 2 squared plus b times 2 plus c. 2 squared will give me 4. So this becomes a times 4. And b times 2 is just b times 2, and that's c. Now here's the thing, when I write this, go ahead and write this into the table. When I do that, I want to put the number first. So even though a, b, and c are the coefficients in the general formula, right now they're just letters. And it just looks nicer for us when we have the numbers in front. So we treat this 4 now as a coefficient, and a, b, and c are just variable. The 2 is a coefficient of b, etc. We'll do that one more time with f of 3, and here's my work below. F of 3 is equal to a times 3 squared plus b times 3 plus c gives me a times 9 plus b times 3 plus c. And again, I'm just going to rewrite that into this box with the coefficients written in front, or the numbers written in front. So I get 9a plus 3b plus c. So you're going to work on this practice with the linear and cubic. So for the linear table, it should look like this. You should have an x column with these numbers 0, 1, 2, and 3, and f of x equals, and this is the general formula, ax plus b. And you're going to do your scratch work on the side by plugging in the values of x into each of these. And here your answers are all going to have some letters like a, b, c, or d. Actually just a and b in this case. For the cubic, you'll have d because you have this as your general formula, ax cubed plus bx squared plus cx plus d. You're going to plug these x values in, do scratch work on the side, and enter in the expressions that you get in these boxes here. Good luck with your homework, and I hope you have a quality weekend. Don't forget, we're going to come back tomorrow and work on filling in and building that road. Take care, guys.